This video was produced by the UCD Maths Support Centre in conjunction with the UCD Access Centre. In this next set of videos, I'm going to be looking at what were known as mini-proofs in geometry. So first, a couple of terms. Geometrical cuts. Often when we encounter questions which can be answered with a series of statements and the reasons behind each statement, these cuts could be considered mini-proofs. And we'll see a couple of examples of that in the next couple of videos. At higher level, you're required to learn these two definitions here. Is equivalent to means that something has the same value of measure as or corresponding to something else. So for example, if I was to write the angle ABC, that is equivalent to, and that is normally written by this small symbol here. So we can say that the angle ABC is equivalent to the angle CBA. So while these two things here have slightly different forms, they measure the exact same value, the angle at the vertex B. The second term is if and only if, and an example of that is a parallelogram is a rhombus if and only if all four sides have the same length. So what if and only if means, and is often denoted by this arrow here, so it's like the implies arrow, but with a second piece written backwards like this. What if and only if means that if one side of this statement is true, that means the other is true. So, if a parallelogram is a rhombus, then all four sides have the same length, but if all four sides have the same length in a parallelogram, then the parallelogram is a rhombus. So it's like it's a two-way statement. If the first half is true, the second is true, and if the second is true, then the first is true. Now, before we start looking at some examples of mini-proofs, let's just remind ourselves of the steps to a formal proof, because the same steps should be used in our mini-proofs. So first, we write down the theorem. So if we're asked to prove a certain theorem, we write down its title. So in the case of mini-proofs, this may not be 100% necessary, but what is necessary is to write down what we are given. So we write down all the information that has been given in the question, and if we're not given a diagram, then we should definitely choose to draw any diagrams that we may need to use in our proof. Next, we write down what we're asked to prove, so it helps to know what properties we're trying to use. So if we needed to prove that something was a square, we would need to know the properties of a square. So all angles are 90 degrees, all sides should be equal, and so on. In some mini-proofs, you may require a little bit of construction. You may need some extra lines or angles to help you prove the theorem. So we construct these lines or angles and we label them clearly, and then our proof. And this is the most important part. We write down one reason or statement per line, which will go towards proving what you've been asked to prove. But conventionally, we always finish by writing QED, which stands for the Latin Quod erat demonstrandum, which means what was to be proved. And sometimes, instead of QED, you might see people draw a small square with lines through it like this to signify the end of a theorem as well.